Hi guys, it's Rohan this side, and in this video, I'm going to upload the entire live recording where I have explained about the citizen science project called as IASC, where we search for the asteroids that are mostly present in between the Mars and the Jupiter. That is basically the asteroid belt, right? So in the past, I have been uploading videos in the playlist of how to participate in the IASC campaign. But then because of some kind of updates going on from the IASC side, I was not able to complete that playlist. But now I got the opportunity to collaborate with one of the schools where I have given this live workshop on how to participate in 2025 for this asteroid search campaigns with the help of IASC, and then how you can utilize the Astrometrica software. So everything from the starting I have explained what is this campaign all about, why we should participate, and then at the end, how you can submit your information to the minor planet center so that they can work on that and then finally conclude that if we have found the asteroid and then maybe we are going to name it, right? So it's not always we can name it, but yeah, that is the idea that sometimes we may get chance to name it, but of course our name will be attached as a citizen scientist that this people or this team have worked upon this particular object. So yes, guys, watch this video from the start till the very end because I have explained everything in a great detail. And because it's a live recording, you might want to just speed up the entire video, let's say at 2x, right? Or maybe 1.5x, depending on your interest on how you want to listen to it. And at the times in between, there will be a certain kind of pauses that I'll be taking. Even that kind of parts you can skip. So yeah, I wish you all the very best for this upcoming whatever kind of astro research campaigns you'll be part of, and happy hunting, guys.
So, hi guys. So in this, just like how Kaushik has mentioned already, I'll be giving you a brief introduction towards the IASC campaign that stands for the International Asteroid Search Campaign, and it is collaborated basically in partnership with NASA, JPL, right, and also the Minor Planet Center. So I'll be introducing to all of this kind of things in a proper way so that you will be able to understand and you will be able to actually enjoy the entire process that like what exactly you are doing by contributing to the astronomical society with the help of this one project. Okay, so that is the entire aim of this particular session where I'll be just going through entire journey from how to start and then how to use the Astrometrica software, and using the Astrometrica software how we can tell the NASA people that we have identified something which has not been observed by anyone so far. So all these kind of things will be pretty interesting. And just to confirm one last thing, Edusha, is the recording started? Has the recording started? Edusha, I'm audible to you?
Yeah. Hi. Yeah, you're audible.
Yeah. Okay, and the recording has started, right?
Yes, the recording has started. I'll be just shifting my location for a while because my battery is draining and I have to
Okay,
change.
come. If there is no problem, okay, you can stay on mute and on the entire meeting. There is no problem. Just keep the meeting on. Okay, I mean the recording on.
Yeah.
Okay, thank you so much, Edusha. All right, guys. So I'm just going to start my screen sharing. Just a second. So, all right. So, first of all, I'll just introduce myself to you all. So, I'm Rohan, and I'm currently working as a machine learning engineer, and I'm having around 5 years of experience dealing with machine learning. And at the same time, I'm very much passionate about astronomy. So, I occasionally go out whenever it's possible to do the stargazing and participate in this kind of online citizen science programs. So, yeah, that is what I'm about to do right now as well. I'll be sharing with you all a complete detail about how you can go about this campaigns and what is this campaign all about in the first place, right? So yeah, that was a quick introduction about myself, that I am currently working as a machine learning engineer, and I'm also passionate about this kind of citizen science projects and the astronomy overall. So yeah, that's why I'm over here to guide you all. And in specifically, if I talk about the IASC campaigns, I'm having around 3 to 4 years of experience now, and so far I have detected around 20 preliminary objects. I'll also talk about what are these preliminary objects, how to officially get it converted into a discovery that is recognized by NASA. So all of these kind of things I'll be explaining in a proper detail. All right. So yeah, that was about a quick introduction about me. Now let's talk about the IASC campaign. So for that, what I'll do is just a second. I'll just reshare my entire screen so that you guys can see everything on my screen. And just in case, because I'm having my AI model runnings in the backend, just in case, let's say if my laptop gets hanged in middle while I'm having conversation with you guys, So what will happen? I'll just be leaving the meeting for a while and I'll be just joining back. It will take around 2 minutes of time. In case if I'm not able to join back, then Edusa is going to continue. Okay, Edusa is one of my team members and currently leading another team in the IASC campaign. So I am also a team leader. Edusa is also a part of another team leader. So basically, she's a team leader of a part of another team. So in case if I'm not able to join back because of the issue that I mentioned, Edusa is going to continue from the moment I'll be leaving the meeting. And I hope that this doesn't really happen. This happens very occasionally. But yeah, fingers crossed that this doesn't happen in this particular meeting. So for now, so let me take you towards the overall idea of the IASC campaign. So IASC, as I mentioned, it stands for the International Astronomical Search Collaboration, where we come together across the globe, where we are trying to contribute to this astronomical society about if we are finding some kind of unknown, that is undiscovered objects that are revolving around the earth. We also call them near earth objects. Okay, it could be comets, it could be asteroids, right? So any kind of objects which is unknown, like no one has identified so far, and we are going to be the first guys to identify this kind of unknown objects and then report it to a particular firm called as Minor Planet Center. Okay, so what is this Minor Planet Center? So there are this kind of people working as a part of a team, where if we are sending them this kind of an information that what, I have detected some kind of unknown object. So is this unknown object really worth of calling an asteroid or a comet or whatever it is? Mostly we'll be detecting asteroids in this campaign, as the name suggests that we are dealing with the asteroid search campaign, right? So mostly 99% of the times, or I should say 99.999% of the times, you will be identifying the asteroids in this campaign. So what we do is we initially send some of the information to the Minor Planet Center, or in short MPC. So we send the information, we send our data to the MPC guys that see in this images that you have sent us to go ahead and look into it. And the images are basically coming from the Penn-STARRS telescope. Okay, there are two different telescopes out there, and they are called as Penn-STARRS 1 and Penn-STARRS 2 telescope. Okay, you can find that out on Google if you want more details about this telescope. So we are getting live data from, let's say for example, right now we have registered for the September to October campaign. So from the September till the October, whatever kind of recordings that Penn-STARRS telescopes are doing, they'll send these images to us, and the campaign has already begun. Okay, so I'll be giving you some of the image sets that I'm going to try over here that has been sent by this IASC people directly to my team. I also forwarded this kind of image sets to Kaushik. I'm sure that he must have shared with you. So we are going to work on three different image sets, okay? Three different images. And it is coming from 19th September. So today is 22nd September, but we'll be dealing with 19th September because I received this image sets from the 19th September. All right. So the Minor Planet Center is responsible that if we are sending them some kind of a data that, what, we have identified something that is unknown. No one has ever seen that particular object. Now, is this object really an asteroid or just our assumption that it is an asteroid? So they are going to spend around a week time to process this information. And there is something called as faint detections and numbered discoveries. So first of all, the first process is the faint detections. So what are these faint detections? The faint detections are classified into two different groups. The first group is called as preliminary detection, that you can see over here, right? And the second group is called as provisional detections. So what is the difference between the two? What is the difference between the preliminary detection and then what is the difference between the provisional detection? What is the main difference between the two? So when we send some kind of information to the Minor Planet Center that we have identified something, can you please confirm if this is an asteroid? So there is three different process. The first process is a week-long process. So every Thursday night or maybe Friday night or a Saturday night, they'll send us a confirmation that if you send something for them to check, within a week they'll tell you if this is something worth studying about. And at the end, this study is going to be conducted by the people at NASA, specifically Jet Propulsion Laboratory. Okay? So if you are not really sure about the JPL is a part of NASA itself. So they are going to study about this information that we are sending for 5 years. Okay, for 3 to 5 years is an ideal period, but then they are going to study it for 3 to 5 years. So I told you that there are three different stages. The first stage is 1 week period. The second stage is 1 year period, and the final stage is 3 to 5 years of period. So in the first week when we are submitting our details to the Minor Planet Center, we spend around a week time to confirm that yes, there is some kind of a data on which we can trust and study it for an entire year to identify its initial orbit. What do you mean by the initial orbit? That if we are sending that, you know what, in this part of the sky, there is an asteroid that is moving, that we hope that that is an asteroid which is moving. So what they do, they first of all, in the 1 week time, they identify that yeah, if something is really moving, or is it just our assumption, or it could be that sometimes we are sending some kind of information which does not get selected. But then if it gets selected in the 1 week period, that is called as preliminary detection. So what is the preliminary detection? A detection that is done within a 1 week period, that then gets studied for an entire year by the Minor Planet Center people only. At Minor Planet Center, they are going to spend around approximately a year time, 8 months to a year time they are going to spend, and then they are going to identify the initial orbit. Because now they are having the location that on what part of the sky this kind of object is moving. They are going to trace that location for an entire year. They are going to spend some time for an entire year or approximately a year, and then they're going to identify the initial orbit of that particular object which is unknown, which has never been discovered so far. We are the first one to report it, right? So they are going to spend entire year, and once they are done spending an entire year of research on, like, if the object that is moving is having an initial orbit or not, right? So if they are able to confirm that yes, there is an initial orbit that we have identified, we as in Minor Planet Center people have identified, then they convert our preliminary detections into provisional detections, and they send you, like, you as in they will send your team leader, whoever is your team leader, they are going to get a complete report, a report where in which they are going to tell you that, you know what, that this is the part of the sky, and exactly in the asteroid belt. Most of the identification that we are going to do are going to be in the asteroid belt region. What is the asteroid belt region? It's a region of space in between the planet Mars and Jupiter, right? Because of the immense amount of gravity that the Jupiter has, the Jupiter planet has, right? It's the gas giant planet that we are having in our solar system. So because it's the, like, huge amount of planet, the amount of gravity that it contains is so strong that there are all the kind of asteroids. Most of the asteroids in our solar system are trapped in between Mars and Jupiter. So whatever kind of detections that we are going to make, mostly it is going to be from that asteroid belt. And if we get lucky, we might get something that is, like, trans Neptunian object. So that is beyond Neptune. Okay, any kind of object that we are able to identify that is after Neptune. Okay? We can also mark that, but that happens very, very rarely. Most of the times, what I have personally seen in my journey of 3 to 4 years at the IASC is that mostly we'll be getting our details of the data from the asteroid belt that stays between Mars and Jupiter. Let me show you how it looks like. Just a second. Asteroid belt. So here is the image of the asteroid belt. You can see that the sun is in middle, and then there is an orbit of Mars, there is the orbit of Jupiter, and just in between the Mars and the Jupiter lies the asteroid belt. So we are from the Earth, there is a telescope called as Stars in Hawaii, right? So from the Hawaii we are getting this kind of data, and from that data we are trying to observe different part of the sky. There are multiple teams who are participating over here, so depending on different kind of scans of sky that these telescopes are making, all of the teams are going to get different parts of the sky to observe and study, right? I'll show you how, with the help of Astrometrica software that you can see right now on my screen, how we can utilize this software to analyze the data that we are getting from the Stars telescope and confirm if there is something which is moving or not, and send the information to the minor planet center people. I'll give you a complete demonstration as we go ahead. But for now, coming back to the asteroid belt, these are the kind of objects that we are trying to find most of the times in this campaign. Okay, so yeah, that is something that we are going to do with the help of this campaign, and you can continuously participate. As I mentioned, I'm over here with the IASC for around 3 years now, right? So for every month by month, month by month, whenever the campaigns are available, you can register for this kind of campaigns and give your contribution in finding this kind of asteroids which have never been seen before by anyone. You are the first one. You will be the first one from your team and the entire world that is going to observe that particular asteroid for the first time. And then just to confirm it, you're going to send it to the minor planet center. Minor planet center is going to spend around a week time, first of all, to just tell you that yes, we do believe in your submission, and now we are going to spend an entire year to get its initial orbit. So orbit may not get completed. Okay, orbit may not get completed in a 1 year period, depending on how fast the asteroid is moving in the asteroid belt. But if they are able to track that, yeah, we are able to find an orbit, okay, then it gets converted to provisional discovery, right? As I mentioned. So far, in the entire history of the IASC campaigns, there are 18,534 preliminary detections so far, out of which only 160, out of this, only 160 of them have been converted to a provisional after 1 year of study by Minor Planet Center. And then I told you the final stage is going to be conducted by the people at NASA. So that is the second type of discovery called as number discovery. So once you are having your initial orbit discovered, Minor Planet Center is going to send the entire data, whatever they have studied in the past 1 year, to NASA. And then NASA is going to track this particular object. They are going to find all the orbital elements. What do you mean by orbital elements now? What is the the size of the orbit, how long it is, how elongated, how stretched it is, then how fast the object is moving, what is the inclination. So if there is an orbit around the sun, what is the inclination of the orbit? I'll be showing you a demonstration how it's going to look like. So NASA people are going to spend around 3 to 5 years of time to identify that whatever was the initial orbit, if that orbit is maintained or not. Because if there is an asteroid, and if the asteroid is not getting impacted by another asteroid or any external forces, the asteroid will always be staying in the same orbit. But now let's say if there is some another kind of object that comes up from the outer space and knocks off that asteroid, what's going to happen? That asteroid is going to go away. Now it's not going to be visible in the same part of sky that we are trying to study. So basically there will be a lot of things going on in the space, right? So if in the 3 to 5 years of period, if NASA is continuously able to track that particular object that we have sent for the confirmation, they convert that to the number discovery. I'll just open that number discovery. Over here in the IASC Hall of Fame, as I mentioned, that there are two different categories. The one is the faint detection. Faint detection has two different categories. Preliminary, that goes for a week time for confirming whatever we submit. Then it is a provisional discovery. In the provisional discovery, they spend around a 8 months to year period to get the initial orbit. And once they get the initial orbit, they directly send this data to NASA. And if NASA, after spending 3 to 5 years of time, if they're able to confirm that yes, this object has continuously been studied, and now we can finally say that this is an asteroid which has been marked by, let's say, Rohan sitting in a part of India coming from Gujarat, right? So all this kind of information gets recorded. Okay, so here is the information about how many of this have been recorded so far. Let me see. So there are out of 160 provisional discoveries, only 89 has made to this numbered discovery. And very recent one you can see has happened in 2021. Nothing after that. You can see that it started from, let me check. It started from 2007. 2007 was the first time where they got a numbered discovery. So you can say that approximately from 2003 to 2004, they must have sent for the initial check. So they must have gone through this process of preliminary detection, provisional detection, and finally the number discovery. Okay. So after getting the number discovery, you can see in this Hall of Fame, they have got this kind of object. And then if I click on this object, okay, if I click on this object, it's going to go to the official NASA website of the Jet Propulsion Laboratory, who have been working on the 3 to 5 years of time, as I mentioned. And here are the orbital elements. This tells you, it tells you about the eccentricity of the orbit. That is how elongated the orbit is. It's not a perfect circle, right? So it is having some kind of an ellipse kind of a thing. So if you don't know what is an ellipse, let me show that to you. So here is the information about that. So when the eccentricity is approximately equal to 0, it's a kind of a perfect circle. Then if you are increasing the eccentricity towards the 1, you can see that it is getting completely stretched, like a circle is getting stretched. So depending on the study that the NASA people have conducted, they give you this kind of information. Not just about that, they'll also tell you about how close to Earth it is or how close to Sun it is. So all this kind of information they'll be recording and studying for the 3 to 5 years of period, and they'll give you all the kind of recordings. So once you grow up and study about the orbital elements, you will be able to understand about everything over here. I have just given you one example, that what does E stand for. E stands for the eccentricity, which talks about how circular or how elongated a particular orbit is. 0 means it's a perfect circle, and closer to 1 means it is a very stretched circle. You can say that over here the value is 0.14, that is closer to 0 as compared to 1. So it's kind of a circular but slightly stretched. That's it. That is the kind of information that we study from this value of E. Now let's see if I want to check where exactly this object is currently. Okay, whatever this object was detected in 2007, what is the current status of it, where exactly it is located. For that, I can click on this orbit viewer. You can see this option of orbit viewer over here, right? You click on the show option, then depending on how much powerful your system is, it will be taking some time to load it. Over here you can see that NASA has created this kind of a simulation of entire solar system, where you can see Uranus, Neptune, Saturn. And if I just zoom in, I told you that the asteroid belt is a region where we'll be finding most of our asteroids, right? So over here you can see that there is a Mars. The red orbit is of Mars. Okay, let me just do one thing. I'll get my pen out so that I can mark something for you guys. So over here, this is a Mars, as you can see. Let me do one thing. I'll just connect my pad so that I can write it in a proper way. Okay, so here is your Mercury. Let me change the color. Here is your Mercury. Sorry. Here is your Mars. This is the Mars that we are interested about, right? In between Mars and Jupiter, we are having our object. Now, if I just zoom out a bit, you can see there is a Jupiter over here. Over here, there is a Jupiter, right? Over here, there is a Mars. Now, in between Jupiter and Mars, you are seeing a white kind of orbit over here. That white orbit is the orbit that whoever had detected this particular object in 2003, 2004, here are the names of the citizen scientists who were involved. And over here, it's not compulsory that you will get your names over here. Depends on, if let's say whatever work that you have submitted, if it's very promising, if NASA people did not have to contribute a lot of efforts, then you will be able to see your name. But now let's say the object that you had submitted was very faint, very faint, and now NASA people have to work a lot more as compared to what work we have done. So in that case, our name will be shadowed over here. So it's not always you will be able to see your name, but 99% of the times you will be able to see your name if you're going to have your detections. But along with your name, you will also be finding some extra names who have contributed in this entire process. And if their contribution is way more as compared to your contribution, their name will be on the top, your name will be on the bottom or on the extreme right side. But regardless of that, you will be mostly seeing your name over here if it's getting converted into a number discovery. So as I had mentioned, if I just zoom in now, if I want, I can also rotate this entire thing. You can see that currently wherever the Mars is, just behind the Mars, this object is present. You might think that every time the object will be located behind the Mars. No, it's not true. This is showing you the correct location, a precise location of where this object currently is present. You remember I talked about the orbital elements? Orbital elements help you predict in future also that where this object will be present. So of course the people at NASA are pretty brilliant, right? They are pretty smart dudes out there who are working on this kind of simulations, who are able to pinpoint even in the future. If you want, if over here there is an option like the overall period of duration you want to simulate. I'm not going to do any kind of changes as of now because my laptop will hang, because my machine learning model is working in the backend. So I'm not going to change any of this simulation duration, but then you can also see in the past, in the future, how where the object is going to be. Okay, so this object is showing correct location, precise location of where it is currently present. So this one is just behind the Mars. I'll show you another example. I'll show you the example of the very recent discovery, which is given a number discovery of 719840. Okay? You can see that 719840 was discovered in 2021. If I click on the orbit viewer, if I zoom in, again you can see it is in the asteroid belt region between Jupiter and the Mars. If I can help you look at, this is your Jupiter, this is your Mars, and in between that you are having your object. And this is the entire orbit that you are studying. See how it is not a perfect circle, right? It is not a perfect circle. It is an eclipse kind of an ellipse kind of a, not eclipse, ellipse, okay? It's a kind of an oval shape that you are able to see, not a perfect circle, which shows there is some kind of an eccentricity which is not closer to zero, which is slightly higher than zero. That is what it showed. So basically over here you can see this object is not just behind the Mars as we saw for the previous object. Let me show you the previous object. Over here you can see that this object, if I change the orientation also, is just behind the Mars currently. And this is the kind of a distance from the Mars. And if I show you this body, you can see that the distance over here is also large, and it is not completely aligned with the Mars right now. And you can also see that this is the current position of the Earth. You can see that Earth is over here, and the object that we have marked over here by the NASA is completely in the opposite direction over here. If I can show you, this is the location that we are where the object is present. Here is the Earth. And yeah, with the help of this kind of simulation, if your telescope is pretty powerful, and if they are able to capture some of the asteroids, which some of the telescopes are able to do this kind of things, you can also try to track this kind of an object if you are interested. But yes, guys, this is the overall idea. This is the, like, a period of duration that starts from us. We are getting the images from the Pine-STARRS telescope. Let me show you Pine-STARRS telescope also, how they look like. Just a second. So yeah, this is the kind of telescope. These telescopes are Pine-STARRS 1 and Pine-STARRS 2 telescope, and they are recording the night sky. Okay, and this night sky picture is sent to us in a FITS format. FITS is one of the format through which we can get a very high quality astronomical data. Okay, so in FITS format, you will be getting this kind of a data, and with the help of this Astrometrica software, we are going to understand how the night sky looks like, and it's going to be highly edited. The images will be highly edited so that we can pinpoint literally everything that is moving in a night sky. It will be that accurate. Okay, so to get that level of information, to see when the minute things they are moving, if we have to track it, they need a high level of processing. So they are going to, let's say, increase the sharpness to infinite. They are going to do some kind of changes in the image processing process, where we are going to get the images which will be not like, you are having a night sky. It won't be a night sky kind of an image, a very highly processed image, so that we are able to pinpoint anything that is moving in the night sky, and we can report it to the minor planet center. And then the minor planet center is going to spend 1 week to confirm if yes, if we can believe on your sample that you have sent us. And then they spend one entire year period to convert it into a provisional discovery. I told you, from 18,500 preliminary, only 160 got this kind of provisional discovery. And from 160, only 89. Imagine, starting from 2007, it's currently 2025. The last object that was recorded as a numbered discovery by NASA after spending 3 to 5 years of time was in 2021, around 4 years from now. right? So just 4 years ago, someone have detected that kind of an object and it has gone recorded. So now once we'll be entering into 2026, 2027, so whatever objects that we have worked on, okay, that we as in the people who started working on this kind of campaigns 3 years ago, 4 years ago, now our if our recorded object gets selected by NASA as a number discovery, soon in future you will be seeing my name also over here in this Hall of Fame list. You will be able to see my name as well over here. But yeah, I'm just waiting for my official number discovery. So yeah, let's see if I'm getting my name over here. The chances are like very very light. But yeah, fingers crossed. And I'm always looking forward to this kind of opportunities where I'm able to find this kind of unknown objects which has never been detected by anyone on the world. I am the first one to look into it, and then I'm partnering with this kind of NASA people to confirm my detection that I have done 3 to 4 years ago, 5 years ago. They are spending their time, they're analyzing all this kind of data. They are able to get the orbital elements about like how circular the orbit is, what is the tilt of the orbit, etc., etc. And based on that, we are getting some kind of information that yes, whatever we have studied 3 to 4 years ago, 5 years ago, is now officially confirmed. Okay, you can see that there is one of the person from India, right? One of the person from India who has got a number discovery as well. You can check that details as well over here. You can see that this is also slightly circular, but more towards the ellipse side. It's not perfect circle basically, and this eye tells you about the inclination. You can see the angle, right? You can also see that it's given in degrees. So it is having a 14 degrees tilt from the normal plane where the earth is orbiting around the sun. There is a 14 degrees tilt to it. So that is what I stands for, right? So yeah, as you grow up, right, you will be studying more about the orbital elements. You can see they mentioned it over here also. So study more about it to understand that where exactly how you can pinpoint. And then once you grow up, once you're having the habit of using, let's say, computer softwares like Python, or coding softwares like Python, right? Or let's say Fortran, whatever kind of coding language you would like to use. So depending on, let's say I am someone who works with Python. So if I am someone who is working with Python, I exactly know how to simulate this kind of data with the help of orbital elements. I have worked with this kind of simulations in my past. And this kind of videos are also available on YouTube. If you're interested, you can let Kaushik know, and I can send information to Kaushik, and he can pass on to all of you guys. And you can see this kind of work if you're interested in how to work with Python, and along with Python, how you can simulate, let's say, Earth's orbit, Jupiter's orbit, how you can do this kind of things. If you're interested on this, if you want to learn on this, we are having this kind of things out there on YouTube. You can just let me know. I can send you all this kind of information, and you can start working on it. I'm not really sure if it is a free of cost available on YouTube or if it's available on Udemy platform. But yeah, I remember working on it as a part of one of the firm that I'm attached with, and they've uploaded the videos either on the YouTube or the Udemy. I'm not really exactly sure because I've been working with multiple projects. So it might, if it's on Udemy, there will be some kind of a price, but if it's available on YouTube, I'll surely send details to Kaushik and he can share it with you guys. Okay. So Kaushik, can you just let me know if the people over there are able to understand all the information? If there are any doubts, they can of course ask me right now before I move on to Astrometrica. Okay, because this was the initial information that I've shared about what are the things that we are dealing with right now, and then once we are getting the data from the IASC people, that is from the Pine Stars telescope, how we are going to work on it. I'm going to about to show that right now. So yeah, please let me know if you guys are having any kind of doubts. I'm very happy to take your doubts. And if there will be a lot of doubts, I'll just shift it at the end of the session. But for now, I can take, if there are some kind of 3 to 5 doubts, I can of course take it. So Kaushik, please let me know if there are any kind of doubts for the students over there. Yes.
So I had
Yep. Basically, you will just have to mute one of the parts that is working in the backend.
so I had a question that like in this the small body database lookup the where we can see the asteroid which is present now. How can we like understand how it orbits after a year in the website?
So there was an option of like, you can simulate a 1 year period. If I can show that to you. Just a second. You want to understand that if I want to see where will it be after a year, right?
Yeah.
So there is an option over here. If you go to your orbit viewer, in the orbit viewer, you can see the animation step interval. You can change it over here. If I scroll down, there is a 1 year option. Just click on that and you will be able to see it. Okay? There is multiple duration through which you can simulate the entire data. Okay,
Yeah. Thank you.
no problem. Any other doubts? All right, guys. Now that you're not having any kind of, let me just check the chat also. Okay, there is no doubts on the chat also. So we are all set. Now to experience how to actually participate in this kind of thing, and how once we detect some kind of thing, how we can send it to the minor planet center so that they can spend an entire week, and then after the week they spend the entire year, and then finally they send this data to the people at NASA to work more upon it, right? So what we do is we go to the IASC. This is the actual website. Okay? I just post the link. See, currently I'm just showing you how to get the data set. Okay, how to get the data set that is uploaded on your team page. So currently I'm going to show you my information about what is my team, but Kaushik will send details to you about your team. You will have to log in from that particular detail. Okay, so I'm sending you the link. So this is the link. You guys can access this link to open this. Right now I've already sent image sets to you that I have been working on in this same campaign, in the September October campaign. So I also want you guys to work on the same image set, so there is no there is no differences between the image sets that we are working on. So yeah, I have already shared this data with Kaushik, and Kaushik must have shared it with you guys. But yeah, let me show you that if you have to get access to this data by yourself, if you are not having any access to, let's say, Kaushik, if you're not having any access to your other teachers, if you're not having access to me personally, in that case, if you have to do it completely by yourself, what will be the step-by-step process, right? So first of all, you come to this website, iasc.cosmosearch.org, then come to login. Now you can get this information of login from Kaushik. He will be telling you the email ID and the password. I'm just logging in with my particular team details over here, and I'm clicking on login. Okay. So my team name is Cosmic Cruisers. So that is why you will be seeing that if I click on campaigns, what do you mean by these campaigns? There are a lot of campaigns in which people participate across the world, not just from the India. Okay, they are participating from entire different parts of the world, and then they come close together and create their own campaigns for different countries or for different collaborations. They create different kind of campaigns. You can see there is from Bangladesh, Colombia, right, Nepal, etc., etc. Currently my team is registered. My team is registered under this Mars G India AKD SA Citizen Asteroid Search Campaign. In your case, you might be registered, let's say, in a different campaign. So please get the necessary details from Kaushik or your respective teachers from whom you can get this information. But currently, because I know, because I am a team leader, so I'm aware about my campaign, it is Mars G India. So I'm just going to click on that. In the campaign, there will be a lot of different kind of teams who are participating over here. So in my case, because I've logged in from my ID, my Cosmic Cruisers team is on the top, and we are registered with the SS Citizen Science Lab. And yeah, I can see my details of, like, all the images that are uploaded. And over here, you will be able to find all the citizen scientists who are participating from Cosmic Cruisers team. Okay, so currently in this team, we are having 3 different members. R Shah is basically me, Rohan Shah. Okay, and I like that I'm having other 2 members as well over here who is participating in this particular team. And now what you are supposed to do, Kaushik or your respective team leaders, whoever is your team leader, will send you the information that you are supposed to work on, let's say this data, or maybe let's say this data. They'll tell you information, let's say via Google Sheet, via WhatsApp groups, or whatever kind of communication your team leader finds it useful for you people, right? It could be from the meetings app or whatever is suitable for your team leaders and you guys. So based on that, if you ask me, I personally communicate this kind of data via Google Sheet. So on a Google Sheet, I upload all this kind of data for different participants or for different citizen scientists. I send this kind of data to them so that they know what kind of data that they need to download. So currently I have downloaded 3 different data, and I have already submitted my report to the Minor Planet Center already. I know what are the kind of data this kind of image sets are having. And over here you can see that PS1 stands for Pan-STARRS 1, PS2 stands for Pan-STARRS 2. There will be only 2 kind of prefix. One is either PS1, that means Pan-STARRS telescope 1 was used. PS2 means Pan-STARRS telescope 2 was used, and then you are getting this kind of a data that it is captured in 2025. 09 means September, and 14 means it's from the 14th September. I mistakenly said earlier that the data is coming from the 19th September, but no, the data is coming from 14th September. Just like this, as the campaign progresses, as the campaign will progress, you will keep on getting new image sets coming from the latest date. So let's say the next image sets that I'll be getting, it might be released today or maybe tonight at around 1 o'clock in the early morning. So at that time, I'll be seeing, let's say, 15th September, 16th September, 19th September, 20th September. So whatever is the latest data that is recorded by the Pan-STARRS telescope, which is available for my team, I'll be seeing all the details over here. And as the campaign progresses, you'll be seeing a lot more image sets. And you just have to download that image sets that are assigned to you by your team leaders. You don't have to work on the entire image sets, okay? Because you are part of a team. All of you guys will be divided into different kind of image sets. So let's say right now I am having 3 different people. So all of the 3 people are working on 3 different kind of image sets that has been given to us. So let's say I have worked upon this. This person V Kirti is going to work upon this, and then the last person is going to work upon this image set. So like this, I have divided this particular thing. Okay. Now I'll be getting new image sets. I will be dividing these image sets into the 3 people evenly, so that everyone are getting equal amount of chance to get the discovery done, right? After all of us are excited and passionate about finding this kind of unknown object which has never been identified by anyone. We are going to be the first one. So it is always better to work in a team. And what is the importance of a team? You are not just burdened alone to complete the entire list of images that has been sent to you. It is always a good thing to work as a part of a team to complete this kind of work in a very quicker way. Okay, so let's say if you're having a very less time, you can participate in a team where there are a lot of people. But let's say if you are someone who is really very dedicated, who is very passionate, and if you want, you can just participate in a team where there are only few members, so that you can get chance to work upon a lot of image sets. And if you're having a lot of image sets, the probability of you discovering something is going to be pretty high, right? So yeah, that is the initial setup. So once you are getting the image set, you have to download that. Once you download it, it will be in the zip format. Okay, so let me show you how it's going to look like once you download it. So the image sets that I have submitted to Kaushik are in the .zip file, as you can see over here. This is one of the examples that I have highlighted. Okay, now you just right click on that and you extract all. Click on the extract all option. By the way, guys, if you are working on your Mac OS, it's not going to work. Astrometrica works only for the Windows OS. So just make sure that you are working with a system which is having Windows OS on it. Okay. So yeah, once you will have this kind of a zip file located, you just have to right click on it and then click on extract all. And if you click on extract all, you will be getting this kind of an folder. And if you open this folder, you will get this kind of a image name, that is XY73P10. If I can confirm, this is this image set, XY73P10. So I am currently working on this image set. Okay. And then if you open it, you will be seeing there are 4 different files. In all the image sets, there will be 4 different image files. Over here, you can see that it is a FITS file, FITS, 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 FITS. As I told you, FITS file is a type of a file which is dedicated for the astronomy specifically, so that we are having the data that is required to capture this kind of things in the high definition. Even the minute amount of things that are moving out there in space, we are able to capture that. So that is why this kind of file type is required to study this thing. Now, because I'm also working with image processing myself. So if I'm going out there doing some kind of stargazing activity, let's say I'm capturing Saturn out there, let's say I'm capturing some kind of moon out there, right? And then I want to do some kind of processing. I require some kind of software. Let's say a Photoshop is there. I'm currently using GIMP software. So depending on what kind of software you are good with, you can install that and you can do your image processing by yourself. So yeah, over here we don't have to do anything by ourselves. We are having Astrometrica software. We are having this Astrometrica software for us to do all this kind of processing just by simple click. If you do it by yourself, it's a very hectic process. So we don't have to go through the hectic process thanks to this Astrometrica software. So yes, guys, what is the first step? Once you are downloading the image sets from your respective campaign team page, right, you will be getting access to the zip file. Once you're having access to the zip file, what do? You simply extract the files out of it. And once you extract the files, what is the next step? Next step is to open Astrometrica. Okay. And just in case if you haven't registered your Astrometrica software for a complete free of use for your entire life, just do one thing. Go to help. In help, there is an option of registration. You click on registration. You can get this information from your team leaders, whoever is your team leader. You can ask them that what is my license and the key. So just get the license and the key and click on OK, and you will be registering your software for your entire life. You can use this software for free and contribute in this kind of asteroid search campaigns through this Astrometrica software. Okay, just have to click on help, click on registration, get these details from your team leaders, and team leaders are going to give you proper information, not just about the login, but also the registration key, so that you can register your software for free for your entire life. Okay, you don't have to do it right now, you can do it later on also. Within 1 month of period, you will have to register your software for free access throughout your life. Okay, so once you are done with your registration, what do? You have to load your images. So which image I am going to work upon first? I am going to work upon an image set that is called as, let me show that to you, PS1 new practice set 2. Okay, PS1 new practice set 2. Please guys extract these files in your system if you are performing with me. Just extract the files of PS1 practice set 2 and let me know once that is ready. Yeah,
Hi, Rohan.
yeah.
I'll have to rejoin the meet because there is some technical difficulty. I cannot see your screen properly, so it's interrupting with your. It's
Okay, no problem. You can just rejoin. I'll just wait for you. No
yeah.
problem.
Just give me a minute.
By the way, guys, others can confirm. Is my screen properly visible? Extract that. And if only Kaushik is doing it, Kaushik, please do this step. Please extract the files from the PS1 new practice set 2 because this is the first file that I'm going to work upon. Okay. Yes, Kaushik. Is it done?
Yeah, the PS1 is open.
Okay, okay. I'm just waiting for Edusar to join back so that the recording is not interrupted. Just a minute.
I've joined the meet.
Okay, okay. Edusar is back. Okay, perfect. Alright guys, I'm just going to turn off my video for now because now the process will be very much intense. I don't want any kind of interruption. Okay, I just want to consume the entire bandwidth. So I'm just going to turn off my video. But just in case if you will be having any kind of doubts, of course I'll be turning on my video and explain you your respective doubt. For now, I'm just keeping it off. Now that we have extracted the files, what is the first thing that we do? We check the configuration. Currently it is PS2 configured. My software is having a PS2 configuration. By the way, guys, I'll just tell you one important thing before we move any further, okay? Because it's an update given by the IASC. So I'm just going to share that with you. Once you come on your team page, there is an option of please download the new PS1 and PS2 configuration files because the one that is given to you
Rohan,
directly from, yeah,
sorry to disturb you.
yeah, yeah.
I think the Astrometrica software is not getting shared on screen.
Oh, yeah, yeah, because I'm currently showing the team page from where they can download the PS1 and PS2. That's why.
Yeah. Okay.
Yeah. All right. So what I was saying is that first of all, you will have to download this new PS1 and PS2 configuration in your system, because the one that is default that is given to you, the default is having some kind of a problem, so that they have given you the new configuration files of PS1 and PS2. Then once you're going to download this, again it's going to be in the zip file. It will be in the zip format, and from the zip format, what you will have to do, you will have to extract the file. So let me show you that process very quickly before we move any further. Okay, so I haven't downloaded it as of now, because I've already done this process in the early 2025. In January only I had done this process. That's why you can't see it in my screen. But yeah, if you just click on it, you just download it on a particular part of your system. I downloaded this in my downloads folder. And from here, what you're supposed to do, you're just supposed to extract the files. Because it's a zip file, you are supposed to extract it. Once you extract it, you will be able to see that there is a PS1 configuration file. What you do, you just copy this file, okay? Right click on it, and where is the copy? Yeah, there it is. So I've copied it, right? Just a second, there is someone who is trying to join Alexa. Okay. So I've copied this file. Now, where should I paste this file? Once I have copied the file, where should I paste it? That is the genuine doubt. So what you do is you go to your this PC, your My Computer. Then go to your C drive. In your C drive, you will be able to see Astrometrica folder. From the Astrometrica folder, you will have to go to settings. You just delete this current PS1 and paste the file over here. You have to delete the existing ps1.cfg file. Just delete this, and also PS2. Delete both of this file permanently from your system. And then whatever is the file that you have extracted right now.
Rohan,
Yeah.
again, sorry to disturb. The
Yeah,
screen is frozen. We are
Oh,
not
is
able
it?
to see any updates on the screen.
Okay. Just a second. Thank you so much for writing. All right. Can you see my screen right now?
Yes, now we can see.
Okay, I guess I just shared my Google Chrome screen, but now I've shared my entire screen. I'll just quickly repeat the process very quickly. Okay. So first of all, once you will be downloading the file, the PS1 and the PS2 file, it will be in the zip format. You just have to right click on it and extract it, so that you get an extracted folder out of it. And here you can see PS1 file, because I have just downloaded PS1. Just like this, you will also have to download the PS2 file over here, the second file. Click on it, it will get downloaded. Once it is downloaded, extract the files, and then copy your PS1 file and PS2 file. Where do you have to paste it? You go to your this PC. In this PC, there will be your C drive. In the C drive, Astrometrica will be there. In the Astrometrica settings folder will be there. In the settings folder, this is your current PS1 and PS2, which is default file, which needs to be updated. So you simply delete this file and paste your new PS1 and new PS2 file over here. This is mandatory. If you don't do this step, guys, you will have a lot of errors. And to get rid of all the kind of errors, this is the first step, that you update your PS1 and PS2 configurations. Okay. Once you are done upgrading them, I've already upgraded that, so that I'm not showing you the process. But yeah, you will simply have to delete the existing files, and then whatever you have downloaded, I'll take your doubt, just a second. Whatever you have downloaded, PS1 and PS2, separately copy the files, then come back to the Astrometrica settings, delete these files and paste it over here. That is the only thing that is mandatory. Yeah, what is the doubt?
So could you share the files link in or
Right
the
now,
chat?
I cannot really do it, because it's not possible for me to do it. If Kaushik, you can share the files from your campaign. If you can download it and share it with your students, it would be great.
Yes, sure, Rohan. I'll do that.
You will just have to go to your team, and from the team you will have to simply download these things. And right now I'll just see if I can copy these files, and if I can paste it. If it's possible, I'll do it. Okay, I'm having this option, so yeah, you guys can try this. If this is working, you can surely try. Okay, so the first one is the PS1. The second one that I have shared is for PS2. Okay. The first one is for the PS1. The second one is for the PS2. If you will click on this link, it will automatically start the download process for you. And you can save it in the respective folders, then extract the files, then go to your Astrometrica settings from your C drive. right? Go to your C drive. From the C drive, go to Astrometrica. From the Astrometrica, go to settings, delete the existing PS1, PS2 files, and then update your PS1, PS2 that you have just extracted in your downloads folder or wherever you have extracted the file. Simply copy this. Don't copy the entire folder, guys. Okay, don't copy the entire folder. You have to open the folder. From the folder, you just have to get the CFG files. That's it. Simply copy this and paste it in the Astrometrica settings folder. That's it. Right now I am not changing this thing in my system because I have already changed it. My PS1 and PS2 files are already updated. That is why I am not showing this process. Kaushik, let me know once we are ready to proceed.
Yeah, we can go ahead.
Okay, perfect. So now what I'll do is I'll simply go to my Astrometrica. So the first thing is I'll have to check the name, the prefix of the file that I'm working with currently. So I told you that right now I'm working with my PS1 new practice set image set. So what is the prefix? Is it PS1 or PS2? It is PS1. So it is my duty to change this PS2 configuration file. In your case, it could be astrometrica.cfg, it could be ps1.cfg, it could be randomly setted over here. Okay, mostly it will be astrometrica.cfg if you're opening it for the first time. But if I have to change this ps, like where am I pointing? Let me show that. I'm pointing over here in the bottom right corner. Okay, over here currently it is ps2. So I have to update this to ps1 because my file that I'm working with currently is ps1, not ps2. So I go to this settings option, that is a blue wrench that you are seeing over here. I click on that. I click on open. Okay, I'll click on this open button that is present over here. And once I click on open, I'll either get an Astrometrica folder or a settings folder directly. So if it's an Astrometrica folder, you can just let me just show that to you how it's going to look like. You might have this kind of a screen, and if you're having this screen, you can click on the settings, and from the settings you can upload this ps1 configuration. Again, I'm repeating, why am I uploading my ps1 configuration right now from the ps2? Because the image set that I'm working with right now is a ps1 file, not a ps2 file. So that is why I have to change this, and then I'll have to click on save, and then I'll have to click on OK. Okay, and now you can see that ps1.cfg has been updated for me. Initially it was ps2, now it is ps1. Now we are ready to perform three different important steps. Okay, so once you are done with loading your data, that is your first step. In the first step, you load your data. Load your data. All the four images that we have extracted, right? All the four images that we have extracted, we are going to load our data into Astrometrica. So how do we do it? We go to file, there is an option of load images. I click on load images. Then I go to my downloads folder, because in my case, it is a downloads folder. If I can pinpoint, yeah, there is my downloads folder. And from here, I have to identify my PS1 new practice set 2, because this is the image set that I'm trying to work with. I'll open that. I'll open this folder and I'll select all the four and click on open. That is how you load the images to your Astrometrica. You can see that currently the images are like, having this kind of dots. I told you it's a highly processed image, right? So this is not how your night sky looks like, but because there is a highly processing done so that we can pinpoint even the smallest thing that is moving out there in space, you are able to see it in this particular color. In your case, maybe you are seeing in this color. So if you want to change this color to the color that I was having, you just have to click on this option called as invert image. Okay, you click on that and you will be able to see now this version of the images. It's up to you, whatever kind of version you want to work with, you can go with that. So the first process was to load our data. Okay, so we are done with the first step. What is the second step, third step, and fourth step? This new three steps are the steps which you can never make a mistake upon. If you are going to make mistakes over here after loading your data, you are going to face numerous errors. Okay, you are simply going to face a lot of errors. So just make sure that you are paying proper attention in these three steps. So after you load your data, what you're supposed to do, there is an option over here. Over here, I'll just change my pen to red color. Okay. So over here, you can see there is an option there is a green color icon. You simply have to click that. That is called as your astrometric data reduction. Astrometric data reduction. If you click on that option, what's going to happen? It is going to connect your images from the PS1. You know that these images are coming from Pan-STARRS 1 telescope. We know that it is coming from Pan-STARRS 1 telescope. Now Pan-STARRS 1 telescope is just showing you how the night sky looks like. But now, because we have to report our unknown moving objects to the minor planet center, there should be a medium, right? How do we submit? How do we submit our information that we have found to the MPC people? Or let's say if MPC people want to tell us that, you know what, the night sky that you are looking at, there are already some of the moving objects out there which have been recorded in past by a lot of other citizen scientists. So if there is an object which is already marked by someone else, you are not supposed to mark that object, and you are not going to claim others' objects as your objects. So how is MPC going to tell us all this kind of information? Or if we are sending information to the MPC, how are we going to tell them that in the night sky, in this position, you are having your unknown moving object? So that is how we connect our data, that in the night sky, whatever I'm watching, okay, there will be some kind of stars, there will be some kind of planets, there will be some kind of an existing data coming from the Gaia DR1 data set. So we are connecting our data set to the Astrometrica software, that, you know what, whatever part of the sky that I'm watching, please do the data reduction on it. The main meaning of the data reduction is you are trying to pinpoint that what is this star, what is this star, what is this star. All the stars that you are seeing out there in night sky, we know that the night sky, the stars don't change the positions, right? The rotation is of course there, that the stars are going to go in this particular rotation, but then all the stars go in that same rotation. So the fixed stars will never change their positions. And because of that, if we connect it to this kind of a database, okay, if we are able to connect to the database will exactly pinpoint that what is this star, what is this star, what is this star, what is this star, what, all the kind of dots that you are able to see, it will be able to connect with the database, and they will pinpoint that, okay, this is the location that you are observing in this image set. And that is why it is very important that we perform astrometric data reduction to connect the database to the night sky that we are looking at. Okay, that is the first after loading your data. What is the second step after this? The second step is to click on the button that is right next to it, that is having a red icon, this one. You have to click on this. What is this? This is moving object detection. Moving object detection. So what happens, guys, in the moving object detection? If you click on that button, whatever are the existing moving bodies that is known by the software, that in the past people have seen that there are moving objects and they have recorded it. So all these kind of recordings, the number discovery that we saw, right, 89 number discovery that I showed you earlier. So all that number discoveries, I'll just do one thing. I'll turn on my screen, my face also, so that you are able to see what exactly I'm explaining. Okay. All right. So what I was saying over here is that all the 89 number discoveries. So if the night sky that you are trying to watch, there might be the number discovery thing that you are seeing which is moving. Of course, it is a moving object, so we are seeing, but it has been recorded by someone else. So software should know that this moving object has already been recorded by some other people or from another citizen scientist. So I am telling software that whatever are the moving objects, please try to detect all of them according to your capacity, and whatever you have connected the database, in the database all this kind of information is already present. If there is a moving object, software will understand that, okay, in this part of the sky there is a moving object that has been detected by someone else. It is not unknown, it is known moving object. Okay, so that was the second step after loading the images. Okay, Astrometrica data reduction is going to connect the database to the part of the sky you are watching. Then moving object detection will tell you that okay, what part of sky you are watching. If there are any moving objects which are already marked by someone else, software is going to understand when we click on this button. Now comes the most important step after this. Of course, all the steps are important. I'm just trying to, give emphasis that all the steps are important step by step. So once the 2 and 3 steps are done, the fourth step is to tell software that from the database, if you are able to find some moving objects which are already known, which are already been recorded by the previous citizen scientist in previous campaigns, so if in the database this information is present, please show us to that on the images. You know it, the software knows it. But how can software show us that software has detected this kind of objects? It is by clicking this particular option. Okay, this option or this button. That is called as known object overlay. Known object overlay. So it means that whatever moving objects that my software has detected, I am just going to put a small square on it. If it is moving and someone else has recorded it, it's not us, it is someone else in the past who have recorded it. They are going to tell you that in all the 4 images that this object is moving, and it is having some kind of name given to it or some kind of a number associated with it, so that while we are performing this kind of we are trying to find some kind of unknown moving objects, we know that this is already claimed by someone else, we can't claim it as ours. Okay, we can't claim this object. If it is already claimed by someone else, we can't change that object to our object. MPC people are going to understand that okay, yeah, in this part of sky someone else has already recorded it. So if we are trying to fool them, of course they are going to catch this, and we will be our team will just have a very serious impact because of that. That these guys are just trying to confuse us, and these guys are just trying to make fool around us. So never do this kind of a mistake. If there is a red square, don't claim that object as yours because someone else has already claimed it. You are supposed to find a moving object without this kind of red squares on it or red circles on it. You are supposed to find only those objects which are moving. I'll show you how to find all that kind of things in just 5 minutes. But if it's in red circle and moving, it means someone else has claimed it. But if it is moving without any kind of red marks on it, it is your object, a object which you have seen for the first time. No one else on the world, no one else. I don't know if the aliens are watching it from from different part of the universe, but at least on the Earth, no one knows that there is an asteroid out there which is orbiting in between maybe Mars and Jupiter, maybe after the Neptune, the trans-Neptunian objects are there. Whatever we are able to detect over here, right? So mostly, as I mentioned, that the object that we'll be trying to detect will be coming from the asteroid belt region, right? So yeah, if it is not having any kind of red marks, it means I can claim that object to be mine. It is my personal object that I have identified, which has never been identified by someone else. So that is that kind of feeling that, oh my God, I am observing some kind of thing in the universe. It's a space rock that no one else has identified. It's floating out there since the early universe, right? When the universe was created, once the solar system was created, this kind of rocks are floating since then, right? So no one else has claimed it. We are going to be the first one to claim it. But now, what is an interesting thing? Not in all the image sets you will be seeing this kind of moving objects. Sometimes there will be night sky where nothing is moving at all, not a known moving object. There will be no this kind of red marks. And once you are trying to find if there is any moving objects, you will not find any unknown moving objects. And there are a lot of cases when this is going to happen, that there is just a night sky, and in the night sky that you are trying to observe right now, there is nothing moving over there. There is literally nothing. So sometimes this kind of image sets will be there. Sometimes what will happen, only the red marks objects are there. You can't find anything unknown. Completely unknown is not present. Something is moving, but it is claimed by someone else in the past. So of course I cannot claim it, or else I'll have to face serious like allegations upon I'm trying to fool NASA people, and I'm just wasting their time, right? And they're just going to disband our team. So we don't want that kind of things to happen. So if there is a red object, I am not going to give my name to it. So a lot of images, mostly this is going to happen where you will be having red objects, but unknown objects are not there. Very rarely what's going to happen, along with the red or without the red objects also. There will be some kind of objects which are moving without red marks. And in that case, you can claim that object to be yours by giving a code to it. Let's say in my case, because my team stands for Cosmic Cruisers, we give object code as Cosmic Cruisers and then some kind of numbers attached to it. There will be 4-digit number and a 3 initials of the team name. Okay, so this is just an example of the code that I have given to you. Like this, your team leaders are going to give code to every citizen scientist who are participating in this asteroid search campaign, and everyone will have a different code, so that if we give same code to two different objects, you are having this clash, that if this object was someone who has related in the past or this is a new object. So to avoid the clash, every time when you detect a new moving object, you give a different code to it. For one object in the 4 images, you give the same code. But now if you are changing the object in one images, there could be more than one unknown moving object. Let's say one object is moving over here, another object is moving over here. So all the 4 objects that are moving in one line over here will have same code. Over here, this is another object which is moving, another object which is moving. So there will be a different code for this. Okay, there will be 2 different kind of codes depending on how many objects that are unknown which are moving. In my opinion, if you ask me, there will be at most 2 unknown moving objects. But then in past, people have recorded 10-12 different kind of unknown moving objects, and not in just one image set, but in the entire campaign. So yeah, you can expect around 3 to 5 at max. Okay, so don't have a high hopes that you will always find an unknown moving object. Astronomy always teaches us one important quality that everyone should have as a human being, that is patience, right? Patience is something all the astronomers should have. If we are not patient, if we are just looking out there for unknown moving objects, if you just get frustrated that I am not able to find the unknown moving objects, you will never be successful as an astronomer. Astronomers have this kind of a unique skill set that not a lot of human beings have, but of course all of the human beings should have this kind of a quality in themselves, that they should be patient, especially if you are an astronomer. Sometimes the sky conditions are not good when you're going out for the observation. Sometimes, let's say the telescope or the binoculars that you're using, there is some kind of a fault with that. You are just trying to wait, and let's say some kind of mishaps are happening here and there. So this hobby of astronomy teaches you how to be patient. You have to be showing a lot of patience. Not in the every image sets you will be able to find unknown moving objects. Rarely in the entire campaign you will be able to find 1, 2, 3. And if you are very lucky, you might expand it to 4, 5, 6 also. But yeah, that is a kind of a thing. I have told you that one of the team has registered in one campaign 12 different unknown moving objects. But that was very rare. Most of the times, if I give you an average number, according to my experience of 3 years, it is around 3 to 4 images for entire 1 month campaign. That is an average number. Okay, so don't have high hopes that every time you will get an unknown moving object. Okay, it will be very, very rare. And if you are lucky, and as if you will be working on more image sets, your probability of finding this kind of unknown moving things is very high, right? So yes, guys, that is the overall idea. First, you load your images that you have extracted. You load the images, then you perform the 3 important steps. And once you are done with the 3 important steps, then what do? You convert all the 4 different images into one image that is moving. That is kind of a GIF that you are trying to create, a moving animation. So how do you do that? There is a last option that you click. That is, this option is called as blink images. Blink images means play all the 4 images in a sequence, one after the other, after certain interval. Over here you can set the interval. This increases the speed of how fast the objects are moving. You can go till 9, starting from 1. 1 is the slowest speed, 9 is the maximum speed. I am currently working with a speed of 6. You can maybe work with a speed of 3, speed of 5, speed of 7, whatever is comfortable for you. Okay, currently I'm working with a speed of 6. But anyways, these are the 5 different steps that you will have to perform, starting from loading the images, then astrometric data reduction to connect the database, moving object detection so that software knows that there are some kind of moving objects, from the database it will be understanding. Then non-object overlay, if you click it, the software tells us by the red marks on the screen that okay, there is a moving object that is marked over here. And finally you blink the images, and in this blinking of the images we are able to see that if there is something moving we will be able to see an animation. And if something is moving, it is not having any kind of red marks on top of it, you can give that object your own code that is assigned to you by your team leader. And if you are able to do this, you are now going to create something called as MPC report. This is the final step, guys. MPC report is a report that you send to MPC people so that they can spend an entire week studying that, and then they can give you a response that if whatever you have sent us is trustworthy or not trustworthy. If it's a trustworthy, it will be converted to a preliminary detection, right? As I had explained this earlier. So this is the final step, how to create the MPC report. So there are 3 different types of MPC reports that you will be creating. What are the 3 different types? I'll explain that at the end. First of all, let me perform this step 2, 3, 4, and 5 and show it to you how it's going to look like. So I'm going to first of all click on this green button so that the astrometric data reduction happens. And whenever you are doing this process, please don't touch anywhere on the software. If you will be touching on the software, and if your software is if your system is not powerful, it is going to crash your entire system. You will have to restart the software and everything. So for that to not happen, just be at a safer side. Don't click anywhere on the screen when the process is happening. So now you can see that all of my 4 images that I had uploaded is connected to this database Gaia DR1. After that, you can simply close that and click on the second one, that is moving object detection, and click on OK. You don't have to change any kind of settings every time. Click on OK. And this is the most time consuming step, where software is understanding the data set which we have connected and trying to observe that in my night sky, if there are any moving objects according to this database or no. If there will be, software will be able to understand it. We will yet not be able to understand. For us to understand, we have to click on the third button over here, the known object over here. So we are just going to wait for the data reduction to be completed. It will take around a minute's time. But yeah, this is the second important step. After you connect your database to the night sky, now software needs to understand if there is something moving over there or not. That is already recorded by ex-citizen scientist or the citizen scientist from the past. And over here, you simply have to close this. Now, my software knows where are the moving objects. Now, how software will show it to us? By clicking on this known object overlay, this button. I'm going to click on that. If there will be any kind of known moving objects, guys, then it's going to show it with a red circle. The object will be moving, but it is already recorded by someone else in the past. We can't give our code to that kind of objects. Remember that. You can see that there is one red dot over here. Right? Let me highlight that. So there is one red dot over here and another red dot over here. It means software has detected a moving object that has already been recorded in the past. And these are the 2 parts of the night sky where we can see it. Sometimes what will happen, you will just see a red circle in which the object is not present. So there is some kind of a miscalculation that has happened by the software, and we don't really care about it. If there is a circle, it means someone has detected some kind of an object. It's just that the software was not able to exactly pinpoint it in the night sky. This will happen very rarely. Sometimes what will happen, there will be some kind of mismatch. There will be some object that is moving, let's say 1, 2, 3, 4, and the circles will be over here 1, 2, 3, 4, not exactly on it. So sometimes there is slight amount of a difference in the thing that you will be seeing, and most of the times you will be seeing that the circle is exactly on the moving object. But yeah, you will just have to make sure if there is a red circle, you don't touch that red circle and don't claim it yours. It is already claimed by someone else. It is not our property anymore. Okay. So yeah, now let me show you. After I am done with the 3 processes, the final step is to blink the images. I'm going to click on blink the images. And now you can see that the red dots are suddenly moving. Right? not just the red dots, all the 4 images that we had loaded is now playing in a sequence. One by one, it is playing in a sequence. You can adjust the speed of the movie by changing the speed from 1 to 9, whatever suits you. I am currently using a speed of 6. Now, of course, you don't have to do any observations with this much amount of zoomed out image. You will have to zoom in. You will simply have to zoom in a lot. There is an option of zoom in over here, the plus magnification icon. Okay, over here, this is the button that I'm talking about. This one. Okay, just click on that twice. I click on that twice. You can click more than twice if you like. So in this case, that is the thing that I see. Okay. Now, PS1 is a huge telescope. PS2 is a huge telescope. It works on different kind of plates, and that is why you will be seeing this kind of a gap sometimes. Okay, and sometimes the data will be corrupted. You will see half of the image is simply blank. There is nothing out there. It's completely fine. Whatever is visible, we are supposed to study only the visible part. Okay, and there will be mainly 16 different squares. Okay, there will be 16 different squares. Let me show that to you. So this is your square 1, this is your square 2, this is your 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you have to study all these 16 small squares, and you have to identify if something is moving or not. As I mentioned, rarely you will see something is moving, and that is not claimed by someone else. But yes, as an astronomer, we have to be patient. We have to keep on participating campaign by campaign, campaign by campaign, campaign by campaign, and just hope that we are lucky to find this kind of unknown moving objects. Okay. So now what is our duty, guys? Our duty is to start from the extreme top left. I'll just take this scroller and keep it extreme top and the horizontal scroller to the extreme left, so that I am focusing on my first square. And then I'll try to see if there is something moving, if there is something moving over here. Okay, there are certain kind of traits that we need to keep in mind. If something is moving, something needs to move in a straight line. Just imagine if there is a star, if there is an asteroid which is moving in an orbit, it will move in a single line. It will not be like it will go from up to down, down to up. It will not move like up and down motion. Because in space, if something is moving in a particular orbit, it will always keep moving in that orbit until some external forces are acting upon it. Right? Like let's say some other rock is hitting that object. The first object is going to change its orbit. But mostly what's going to happen? You will see that the objects are moving in a straight line. 1, 2, 3, 4, and the distance between them will be approximately constant. You can see that the distance between these objects will be approximately constant. And if let's say the distance is very small, very small, you may think like that something is moving, but the distance is very small. You don't consider that to be your object. That is some kind of a glitch. And just look at this part of the sky, this part. You can see that something is moving, but it's not properly circular. And if it's not circular, 100% it's not an asteroid. It is some kind of a glitch that we are observing over here, that may be coming from the atmospheric disturbance, or maybe from some kind of a telescopic disturbance, right? So there is some kind of a glitch that we are seeing. Your objects need to be perfectly circle, and then it should be moving in a same direction. It should have equidistant spaces, and the spaces between the moving object should be huge. It shouldn't be very small. That one object is over here, the next is just below it, the third one is just below it. It is just again some kind of a glitch that you're observing. Okay, so these are the 4 important things that we will have to see. The object is circular, it is moving in a straight line, there is a proper gap in between them. That's it, just keep that in mind. Now I am not going to go through the entire 16 files. I'll let you do that in your free time. But yeah, now let's say that I've gone through all the 16 files, because I've already worked on this object, guys. On this image, I already know where my unknown moving object is present, because I have worked on this just a night before. I'll tell you where it is present and how it's going to look like. Over here, if you can notice, over here, there is an object which is moving, and it does not have a red dot on it. There is no red mark on it. So this object is mine. I can claim this object to be mine. Okay, I'll just take, I know that it's already time, it's already 5 o'clock. I'll just take 10 extra minutes. I hope that is fine, Kaushik. Kaushik, are you there? Am I audible, guys? Just give me confirmation if I'm audible.
Yes, you are audible.
Okay, Kaushik, are you there? Okay, is any student over here able to talk to me? Any student present in the meeting? All right, guys, I'm assuming that there might be some kind of a issue at your end, but now because I have to complete the meeting over here, where I have to do the entire process, I just take 10-15 more minutes. Where if you like, if you can, if you're having some other works to do, and if you're over here with me, if you're able to see me, if you want, you can of course leave the meeting. If you're having some other works at your school, of course I can understand that. But what I'll do is, whatever is the remaining part, you will get that as a part of your recording. In case if you are not able to stay with me right now over here, okay, I'll just complete the process. And if you're over here with me, you can continue watching this particular meeting. You can be part of it. And if you're having some kind of work to attend at your school, of course you can leave the meeting. There is no issues at all. Okay. And in case if you will be leaving, thank you so much, guys, for attending this workshop. And thank you so much once again about listening to me. And I hope that this has motivated you to take participation into this kind of campaigns, not just once, but multiple times. Okay. I'm just about to show you one final thing, that is how to create your MPC report. There are 3 different versions of creating the MPC report. Okay. I'm just going to guide that, and we are done for the entire workshop. Okay. So I'll just proceed over here because Kaushik is not responding me. All right. In case, once again, I'm repeating, in case if you have to leave the meeting, you are free to do so, guys. Okay. All right, guys. So, yeah.
It has been very clear for the students, and we are also here. I've also been taking them through whatever my experience has been.
Okay.
So it's
Perfect.
clear so far.
All right. Perfect. So, just for the sake of the recording, I'll just be continuing. In case, Kaushik, if you are having the other schedules over there, feel free to leave the meeting. Okay. Thank you so much for that.
Sure. Thank you, Rohan.
Okay. Okay. Kaushik. All right, guys. So, continuing with the recording at least. If the people over here might be busy, they'll be leaving, but we can continue with the recording, of course, right? So over here, what we are doing is we are trying to identify this kind of unknown moving objects. Okay, I'll also show you how the objects are going to look like if there is a red mark on it already. So let me just try to find those kind of objects. Just a second. Yeah, over here you can see on the this part of the image, there is some kind of a black object on which there is a square. If I can zoom in. Yeah, over here, that is the thing that I'm trying to show. This part. So over here, the object is moving, but now it is also having a red mark on it. It means someone else has already marked it. I can't mark it. Okay? But then if I showed you the first example, right? In the practice set, if you go to the extreme top right, in the extreme top right, there was a, oh yeah, over here, there is an object. There is this part. Over here, there is no red mark, so we can claim it as our object. Now, how do you claim it, right? Let me show that to you. You will have to stop the blinking by clicking on this red dot. Over here, you stop the blinking, and then you can use this kind of arrows to go to your first image. And then you can just manually 1, 2, 3, 4. You can play one of all the 4 images at your own speed by clicking on this next. What you have to do, you have to come on the first object, right? You have to come on the first image, and you have to click on it. The moment you click on it, you have to observe the SNR value. If the SNR value is anything that is greater than 3 or 3.5, if it's greater than 5, it is best. But sometimes what's going to happen, the SNR is going to be in the range of 3.5 to 3.5 to 3.8, 3.5 to 4. And even that kind of objects are accepted. If it is greater than 5, SNR basically means signal to noise ratio. Okay? So signal to noise ratio basically talks about whatever that is moving, it is not the noise that you are recording. It is actually the moving object which is unknown that you are recording. Higher the SNR, you are having more chances that that will be accepted. This object will be accepted as an unknown moving object. As I told you, it will be converted into a preliminary detection when they are spending a 1 week of time If the SNR is high, the probability is very high that it will be considered as your unknown moving object, which is yours. Now, how to claim it mine? There is a 3 dot over here. I just have to click on this 3 dot. You can see that they are selecting all the objects that are present in the image. And now I just have to click on OK without clicking anywhere else. And this is the nearest object that has been marked. I have to delete that. I have to give backspace and I have to give my own code. Let's say CSC0000. That is an example of the code. In your case, you will get your code from your team leaders. Okay. Get the codes from your team leaders and claim it yours. Click on accept. And now you can see there is a blue circle. Blue circle means it is now your object. Okay. Now what you do, you click on the next image and then click on the object that is moved. Again, click on the 3 dots. And now click on OK. Say this, give the same code because it's the same object. It's not the second object. It's the same object. So the code will remain same. Code only gets changed for, let's now there is something else that is moving over here. 1, 2, 3, 4. So because this is a second object, this will have a different code. Let's say CSC0001. This was CSC0000. This is now CSC0001. So if you are marking other objects, you can increment the code by 1. All of this information will be given to you by your team leaders. Okay. So yeah, I just repeat this for all the images. And the thing that you will have to keep in mind is that at least in the 3 images, the object should move. If let's say in all the 4 images it is not clear, but in 3 images it is clear, it is still fine. Okay. Minimum of the 3 images should have this moving objects clearly seen with the SNR value that should be greater than 3 or 3.5. Greater the SNR, as I mentioned, is better. And then click on accept. And now on the final image also I'll mark it. Just have to repeat the same process. Click on the object that is moving, click on the 3 dots and then give your object code that is assigned by your team leaders to you. Now once I am done with this, guys, I can start my blinking and then start moving and searching for other unknown moving objects. In this case, as I already mentioned, there is no other extra moving object. This is the only one moving object. So that is what we have marked. But in reality, you will spend around 15 minutes of time scanning the entire images and try to find the unknown moving objects. And if you locate it, pause the blinking and mark it your object. And then you can start moving to the next square. You can move to the next block and try to continue until you are done exploring the complete image set. Okay, all the 16 blocks you have completely seen. And then once you are done, now you know that there is no other unknown moving objects. What you do, you click on file. There is something called as view MPC report file. Click on that. Over here, now you are having the MPC report file where you are seeing there is a mistake over here. There should have been 4 zeros. I'll take it out just a second. So over here, there should have been 4 zeros. I'll tell you how you can fix the error in case if you are having some kind of errors like this. What you have to do, you have to copy this MPC report. You have to copy this MPC report. Then what you have to do, you have to go to your campaign. In your campaign, what you do, you have to scroll down. You will be seeing this kind of names over here. You have to select all the names because it's a teamwork, right? Everyone is working on a different set. So we have to say that every of my team members have worked on it. So I have to select all the members compulsory. Then I have to select the practice set that I worked upon. It was PS1 new practice set. So I'll click on that. And then I'll come to the MPC report part and paste my report over here. And I'll just fix my error by adding 0. That's it. Now I have fixed my error and now it is all set to submit. Because I've already submitted that, I am not going to submit it. But in your case, because you are working on new image sets, you can submit it and you will be able to see a tick mark once it is accepted. Sometimes you will see some kind of errors over here. If any errors, if you are saying in your case, please approach your team leaders. Your team leaders are going to help you sort any kind of errors that you are getting. Okay. So yeah, what was the doubt? Someone has raised their hand. Any doubts, guys? Thank you so much, Rohan, for your support. I'll have to move out of the meeting as the students is too. All right, perfect. All right, guys. So now continuing back. So this is one type of MPC report where you are having 100% at least one unknown moving object. Now let's say there is a case where there is no unknown moving objects. There could be red marks. there could be red marks which is moving, but there is no unknown moving objects. In that case, how do you prepare the MPC report? Over here, how did we prepare? Whatever was the unknown moving object, we just marked it and gave it our code. And once we are done with that, we copy the MPC report from here and then submit it from the website by selecting all the citizen scientists, by choosing the exact name of the data set that we have worked upon. And then we click on submit and the reports get submitted, and then MPC is going to study about it. And then if it's getting converted to the provisional discovery, NASA is going to study on it, right? So all of that things they'll take care. The only thing we have to do is we have to submit the correct MPC report. There shouldn't be any kind of an issue over here in the MPC report. That is the important part. Okay, so now let me talk about in the scenarios when there is no unknown moving object. In that case, how to create the MPC report. If there are unknown moving objects, you know how to do it. You simply have to mark those unknown objects, give your code, and you are done. If there are 10 unknown moving objects, give 10 codes. If there are 2 unknown moving objects, give 2 codes to both the objects. And then like this, you will be able to see either of the 3 or 4 images, depending on how many times it is visible. Okay? And then what to do, guys, if you are shifting your image, it is very important before you do that, you close all of these tabs. You close all of the tabs and then click on file. After you click on file, click on this reset files. If you click on reset files, what's going to happen? Now the MPC report has been deleted. If you don't reset your files, upload new images, both the MPC reports will get merged. The previous data and the new data will get merged. You don't want this kind of merging, and that is why you have to click on reset files if you're going to work upon a new image. So because I already know one of the example of the image where there are red circles or the red marks, which are the known moving objects, but there are no unknown moving objects. In that case, how do I create the MPC report? I'll show you what file you have to upload. Click on load the files, go to downloads. The image that the image that Kaushik might have given to you, that image in which there are no unknown moving objects, it is 005 PS2 20250914 XY73 P00. Just extract the P00 file first. If it's in the zip format, please extract, else you will not be able to see it. Okay, you have to come to your downloads folder or wherever the image is present. And if you're having the zip file over here, there is a 00 zip file, you will have to extract the zip file. Once you are extracting, only then you will be able to see it over here. Because I've already done this process, you can see in my screen, it is visible. Again, I'll have to load all the things, all the 4 images for the new image. Hey, yeah, I'll open it. And then the first 5 processes constant in all the images. Load the images, do the connect the database to the system, to the software, let software understand the moving objects, then let software show us that yeah, there are some moving objects, and then blink the images. So I'm going to perform all the steps after loading the images. I am performing the astrometric data reduction currently. I am trying to connect my Gaia DR data 1 to the software. Again, I don't have to touch anywhere on the screen. Once that is done, cross this, go to moving object detection, click on OK. This is the thing that is going to consume most amount of your time. Let's wait. This is the part that is going to take the most amount of time. Please make sure if your system is not powerful, it's going to take even 5 to 10 minutes. You simply have to wait. You don't have to touch anywhere on the screen. If your system is pretty powerful, of course, it will happen within a minute or 2. In that case, you are pretty fine. But if you're having a system which is not powerful, it hangs a lot. In that case, you might have to wait for 5 to 10 minutes as well in this step when you're clicking on moving object detection, because this is the most intensive step in the data processing. Software is able to connect the database to the software, and then software is able to identify where these moving objects are present. And because it is scanning the entire image, it is the most time consuming step. Sometimes what's going to happen, you are going to face some kind of a reference star errors. Whenever you face some kind of errors, you don't have to worry, guys. You simply have to connect to your team leader, show them this is the error that I'm getting, and your team leaders are going to help you solve it. Now I'm going to cross everything, and last step is to tell software that now show it to me whatever kind of unknown moving objects, or sorry, if there are any kind of moving objects which is already known to you, show it to me by the red squares. That is the known moving, I mean known object overlay. That is what we are doing. You can see 1, 2, 3. There are 3 different known moving objects, and then I'll just blink the images. After blinking, I'll zoom in twice. And in this case, because I've already gone through the entire image, there is no unknown moving objects over here. There are no unknown moving objects. But then if I can show you, there are some kind of known moving objects. So in this case, how do I prepare my MPC report? In this case, what you are simply supposed to do is choose any one of the object that is already moving and marked. What did you pause your screen sharing, go to your first image if it's not already paused on the first image, and then you click on the dot just like how we used to do it. Click on these 3 dots, but now you don't give the name, you don't give your own code. You click on accept directly with the code that is displayed on the screen. Click on OK and click on accept. Don't give your code. Go to the second image, click on the thing, click on the 3 dots. Again, it will show you the same name. The name will not be different. Whatever was the name that was shown in the previous image, that will be the same name shown over here once again. Click on accept. Do it for all the images. 1, 2, 3. Okay, I guess I've done it 1 and 4. So I'll have to do it in the 2 and 3. In this case, the only difference is I am not giving my code because this is not my property. So I'm not going to give my code. Click on OK, click on accept. And then final one. At least one object needs to be marked. Okay, at least one object needs to be marked if something is moving, so that we are confirming with the MPC guys that whatever is moving, we are confirming that the software is working fine. Okay, click on OK, click on accept, and you can continue the blinking, and you can see that now there is a blue mark on top of the red mark. You just have to mark any one of the moving objects. It's not compulsory to mark all of them. If you wish, you can mark and tell MPC that all the moving objects in this is perfect, up to date. Okay, but yeah, to save your time, you can just do any one, and then again go to file, click on MPC report file, and now you can see that there is no extra space that you are seeing as compared to your previous image set. You were having some kind of spaces before the names, right? You get the spaces before the name if you give your own name. If you don't change the name, if you keep the same name, there will be no space. So this tells the MPC that, okay, yeah, some team has confirmed that there was an object which was moving and it is correct. It means that they don't need to update their software. Okay? So I'm going to copy this MPC report. I'm pressing Ctrl+C, or you can right click and copy it. It's your choice. Then again, I'm going to go to my campaign. In my campaign, I'm going to come over here. I'm going to replace this, paste my MPC report, and again I'll select all my team members, and then I'll choose my P00 because that was the image that I have been working upon, and then I'll click on submit. Simple as that. Again, in case if you're getting an error, please reach out to your team leaders. So I have told you 2 different ways on how to create the MPC report. The first one is where you are having unknown moving object. Second one is where you're having no unknown moving objects, but red squares are there. So you can mark them and tell the MPC people that whatever software is able to detect, it is up to date. You don't have to update the software. And last option of the MPC report is when you neither have a known moving object, there is no red squares in the entire image, neither you are having unknown moving object where you can claim that it is my object. In that case, how to create MPC report, right? That is the final thing, and we are done. So how to do that? For that, I'm just going to use the same image set over here. Or else let me do one thing, because I want to show you how exactly you're supposed to do it. I'm just going to click on reset files. Oops. I have to click on reset files. Okay. And then, of course, guys, I did a small error over here. What was the small error? I did not change my PS1 to PS2. My image set, if I show you very quickly, this one, this was starting from PS2, if you can read it, right? So it was my duty that I changed this to PS2. How do I do it? Again, I go to settings, From the settings, I click on open and I change it to PS2. Click on save and OK. And now you will just have to repeat the process. That's it. Okay, just repeat the process, create the MPC report once again, and then you can submit it. In this case, because I have not changed it to PS2, over here when I click on submit the report, I'll get an error. Okay, I'll get an error that this is not a correct MPC file. And in that case, you just have to check whether your configuration was correct or not. Mostly this will be the problem. Okay, and if that is the problem, you can change the configuration file, load the images, and now you exactly know where you are supposed to mark. Just repeat the process very quickly and you are done. Okay, now what I'm going to do is I'm going to show you one more image set. That is the final image set that you are dealing with. It is having P10 written, not P00, P10. So please extract this file and open it in your Astrometrica. In this, there is known moving object. There is also unknown moving object, but we are going to pretend that there is no moving objects at all. In that case, how are you going to prepare the MPC files? Okay, I'm just going to perform all the steps very quickly. If you want, you can just forward the recording for the steps. Okay. Even this teaches us patience, right? That we are patiently waiting. We are not touching anywhere on the screen. Yeah. Currently, I'm performing moving object detection, the most time-consuming step. So once again, I'm repeating. In this image set, we are assuming nothing is moving. But yes, because I've worked on this, I know that over here there are some moving objects which are known and also unknown. And in this image set, what you're going to do is you're trying to identify where is that one unknown moving object and show it to your team leader. And then if your team leader accepts it, you can, of course, you cannot submit the MPC report because you are not part of my team. But yeah, just a practice, right? You can just confirm it from your team leader that whatever you have highlighted, create a video of it, show it to your team leader that this is the video of the moving object and this is what I have created an MPC report. Ask to your team leader that if my MPC report is correct or not. Okay. So in this image, 100% there is at least one unknown moving object from which you can create the MPC report. Just like I have taught you how to create it when there is an unknown moving object. You just highlight them, give your report, and show it to your team leaders. And every time you're going to show it to your team leaders until you become confident. Once you are confident, you can start submitting it by yourself. Okay. So I'm done with my known moving object. Moving object detection. Now I'm going to click on known moving object overlay, so that if there is a moving object that is identified by the software, it is going to reveal it to me now by a red square. Let's wait for that. So of course they have given you 2 red marks. Assume there is no red marks. Assume that in this image there is no red marks. And then you have gone through all the 16 blocks of the images. After blinking, you have read all the images and now nothing is moving. Let's assume that. Now in that case, how to create the MPC report? Randomly click anywhere. Randomly click anywhere. Click on the 3 dots. Now just give any kind of a random code. That doesn't really matter. Give any random code. And then now you click on the MPC report file. Over here you have to copy this. Okay, let me copy this. Now you come to your campaign, paste it over here, and you have to replace this line, create the quotation marks, double quotation marks, and write no moving objects. Object was seen. And then you can click on submit. In this case, what are you informing MPC? You are informing the MPC people that there is neither known moving object or unknown moving object. This is a part of sky wherein at the time of recording from the PS2 telescope, there was nothing which was moving. Okay, there was nothing which was moving. And then you can click on submit. And then of course, if you're having error, again, you can reach out to your team leader. But yeah, this is the correct way of creating the MPC report when there are no moving objects at all, neither known nor unknown. And once you are done with that, now you know that how to create 3 different MPC reports. First one, where there is a known moving object, you click on them, give your code, submit it. Second, when there is no unknown moving object, but red squares are present. So you select any one of the red square. Uh, don't give your name. Just click on OK, 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 accept, 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 and then create the MPC report. And the third and the final one is where there is no moving objects at all. What you do in that case? Randomly click anywhere on the screen. After you are clicking, give the object code. And then once you're giving your object code, you remove that line when you're about to submit and give the quotations, and within the quotations write no moving object or C. And then you can click on submit the report. So now I have started, I'm just giving you a summary of whatever we have discussed in the entire meeting. Now that no one is present in the meeting except the team members who are connected to me directly. So yeah, I'm just going to give you a quick overview of what we have done. We started by understanding what is the meaning of IASC campaign, because that was the most important part. That why are we doing all these kind of things? I talked about the number discoveries. I talked about the faint detections to explain you guys that okay, what is the end goal of this project? Right? We spent around in 30 to 45 minutes on that understanding. And then I told you that if you go to the number discovery section, how you can see the entire section of the orbital elements. And then if you click on the orbit viewer, how the NASA people has simulated the entire data, and you can see that where exactly currently that object is present. And then if you want, you can go 1 year ahead, 1 year before, according to the simulation time that you can change from there. And after that, I told you that if you want to contribute it to this process so that you can also get to this kind of a number discovery, what is the process? The process is you need to have a window system. Once you're having the window system, get the Astrometrica software. Once you're having the Astrometrica software, there is a update on the PS1 and PS2 files. Please download this, extract the PS1, PS2 files, and put it in the settings folder of the Astrometrica. Okay, you don't have to copy paste the folders. Only the files that is .cfg. Just replace them with the older ones. Okay, just replace that. Okay. Once you are done with that, open your Astrometrica, and of course, once you are done with the particular recording, you just have to close all of the things. And before you just turn off your Astrometrica software, just click on the reset files. You are just not having any kind of chances of mixing two different MPC replays. Okay. But yeah, over here, a team leader is going to assign some of the image sets. You have to download that, upload that on your Astrometrica. Once you upload it, there are 5 steps that you have to perform. Load, then do the data reduction, that is going to connect your software to the database. And then you click on the moving object detection, so the software understands if something is moving according to the database that we have connected. Then third step is known object overlay. Known object overlay is going to show us that where the objects are there, which has been marked by X or the previous citizen scientist. And lastly, you click on the blinking. Blinking is going to create a stitch of images of all the 4 images. And then we have to study entire image, and we have to identify unknown moving objects. And then there are 3 different ways to create the MPC report. First one, where the where the unknown object is present. The second one is where no unknown object is present, but the moving object is there, which is having a red mark. You can mark that. And the last one is there is no moving object at all. Okay, so I've explained all the 3 processes. And of course, you have to always check over here if the configuration file is proper. And this is the first thing that you check, by the way. In our case, if I can show you, the practice set was PS1, but the 2 other images, the P10 and the P00, is starting from PS2. So we are good to go. Okay. Initially, we had a PS1, but then we converted to PS2 for the other 2 images. In this case, that is the entire process. Once you submit it to the MPC, everything else is going to be taken care by the MPC people. And any kind of update on the detection shall be passed to you by your team leaders only. Okay? And please don't forget to get the information about how to log in and how to register your software so that you can use it for your entire life for free of cost. Get this information from the team leader, and I wish you all happy hunting for this campaign. And I hope that this workshop was helpful enough for you to understand what is the process. I have gone through entire process in the extreme detail so that you can understand it. So yes, thank you so much, guys, for watching this recording, and for the people who had stayed with me for the the first from 3:30 to 5 o'clock who had stayed. I appreciate that, and I am very sorry that I couldn't take your doubts. But yeah, of course, Kaushik is there with you, and all the other team leaders. If you're going to have your doubts, if you're not directly connected to me, if you're connected to me, you can send me your doubts, and of course, I can solve that for you, right? But let's say if you're not directly having access to me, you can ask your respective team leaders that Rohan is trying to explain something over here, but I'm not able to understand. Just send that clip of the recording, and they are just going to guide you that what exactly I meant. Okay. And please don't feel any kind of hesitation to approach to your team leaders. If you are facing some kind of difficulties, if there is any confusion, please reach out to your team leaders. Initially, this kind of confusion will be there, but then you will be sorted. Right? So yes, guys, I wish you all the best for this campaign, and not just for this campaign. I hope that you are motivated to contribute in all the upcoming campaigns that you'll be part of, and I wish you all happy hunting for all the campaigns. Okay, I hope to see you sometimes in the future where you might be part of my team, or maybe I'm working with your team, whatever it is. But let's see what future holds for us, guys. Okay. So thank you so much, guys. This recording will be of approximately 2 hours. It was supposed to be 1.5 hours, but it's fine, right? We just spent some extra little time where we understood everything in great detail.